Okay, so I think we are live on YouTube as well. And so welcome to those who have joined us on YouTube as well as on Zoom. In case you're joining us from YouTube and you're wondering how to get on the Zoom link, the link has been posted on Discord. It's the same link every week, so please feel free to join on Zoom. So in today's session, we want to essentially discuss the fourth weekly programming assignment. The problem was called NPTEL's Got Talent, so that's the one that we will be talking about. And Yash will be guiding you through that one actually. And it's based on disjoint sets union because that was the theme of week 4. And also, since we typically have time for discussing more than one problem in these sessions, Gaurav is going to take over and talk about another fun problem from CodeChef, also based on DSUs, I believe. So with that sort of introduction and preamble, I will let Yash get this session started. Please feel free to post any questions that you have in the chat, and please do keep it interactive. So thanks so much, and Yash, it's all yours for now.
Yeah, thank you, ma'am. So good evening, everyone. So let me just share my screen. I hope my screen is visible.
Yep, looking good.
I will be solving this question. NPTEL got talent from week 4 programming assignment. So basically in this question, there is some there is this event NPTEL got talent, and in this event basically each participant is submitting some kind of video, and the judge give them some point which you receive in an array S, and there are n submissions, and each submission has some some score attached to it. And how the competition goes is, so you will receive q queries of these two types. If it is of type 1, which means the submission marked with number X is being competed against submission marked by number Y in the competition. And so this is one kind of query, and other query is 1 comma X, which basically asks us at the point whether to which participant does query X belongs to. So I hope the question is clear to all of you. I hope the question is clear to all of you. Does anyone want to share their approach? You can unmute and answer.
Could you repeat the question?
Yeah. So this is the question. So like this is just the story part. So basically, what happens? There's this event called NPTEL's Got Talent, and in this each participant like submits his or her video as and each video gets some initial score assigned to it. Now so like in this competition, like some rounds happen, and each round two of the submissions are competed against each other, and the better submission wins, and that guy the owner of that submission get holds of the other video as well. So basically in this question, what we have to answer two queries such that in each there will be these two types of query, like the 0xy, which means this the submission marked with number X will be competed against submission with number Y, and the better one, like the one with the higher score, will win. Or you will have a query of this type 1 comma X. At this point of time, you will have to tell to whom does this X belongs to. So basically my question is, like you might have tried this question. So does anyone want to share their approach? Well, if is there anyone? If not, then I will just I'll continue. Like I will explain the question from scratch. So, so in this question, we are given n submissions, which belong to n different contestants, and each like each submission has some score attached to it. So in okay, wait a minute. So we have like n submissions. We have 1 to n submission, and each one has some score attached to it. Now in this event called NPTEL's Got Talent, what actually happens? So there are two types of query. What will happen in first type of query? They will give like two random numbers, suppose I comma j, and they will like compare si and sj. So if one is better than the other, so suppose si is greater than sj, so what will happen? The owner of this submission is my paint screen visible?
Yeah, it is.
Yeah, okay. So like, did I miss anything over here, or like?
No, I think this is fine. Yeah.
Okay. Yeah. So basically, what happened was, so if some score is greater than the other, so the owner of this submission gets hold of this video as well. And so what we basically have to do is, like the code, like we'll get the queries in form of input, and we will have to answer according to them. So this question is straightforward. Like if you know, this question is a straightforward implementation of a disjoint set union. So let us start with like you have a good, like all of you might have some idea of what DSU is, because this week is based on that. So let us like go with the code itself. So ignore this part. This is just for getting this input output thing. So initially what we have t test cases, and for each test case we have an integer, and the next line will contain and space integer, which will tell us the score. And after that we'll have q queries, and each query will be of either of this type. So let's get started. So for each test case, we have an integer n, and an array of size n, which will tell us the score of each individual submission. And then after that, we get a number q, which tells the number of queries we have. And after that, we have now we have q queries of the type which like we'll have q queries after that. So for that, take those as input. So basically, this is the code for taking the input. Now, so what we have to do, so for every query, so now if the query is of type 1, so I am taking the query as an Python array. So if the so every element of this queries array will itself be an query array of this format, either 0xy or 1x. So if the first element of this query, that is the like individual query is 1, which means our query is of the type 2. So in this case, what we basically have to do is basically find. I haven't defined the function find, but what I can say is find parent of query's first element. Basically, we'll have to find the parent of this element because we are using a disjoint set. We'll be using DSU. How we'll be using? So that is we'll have this people face off, and if this guy is defeating this guy, so we'll merge these two, making this guy as the parent. So that's what we are going to do. So we'll find for else what we'll do. Else we want union of query 2 and query 3. Query 1 and query 2. Query 2. Okay. So so I have written some small pseudo like some kind of code for it. Does anyone have any doubt with this?
Well, why you used query of 0 is equal to 1?
Yeah, so basically, so we are having two types of queries, right? Either of this type where we'll be facing off two submissions, or of this type where we have to check who is the parent of this submission. So basically, I am checking. So this query is basically, so we have this array of queries in which all these queries will be stored. So the query can be of, so if you see the example test case, so there is one query of type 0, 1, 2, which means the query is of type 0, and in which the submission 1 and submission 2 will be competing against each other. So, and this other query is of type 1, in which we have to find the parent of 1. So you see the first, irrespective of anything, the first element of type 0 query will, type 1 query will have this 0, and type 2 query will have 1. So basically, I'm checking which type of query it is, and accordingly, I'm answering the query. Hope you got it, or do you want me to explain it? Okay. Yeah. So basically, here I have to find the here I have to find the parent of it. Now let us define, like, let us write our these functions. So in union find, we have two operations, merging, there's this union of two set, and finding the parent. So let's write the code for find. So what we are doing, we are finding the parent of some element else. But before that, let us define an array of array parent, which will this array parent will store the current owner of this ith submission. So it will be list of range of. Okay. So what I have created is, so this like if you print this list parent. So this will be just a list from number. Okay, let me check first. Okay. So now so this parent basically tells us that the owner of first submission is a number candidate number 1, and the owner of second submission is candidate number 2. So that's why we had this, we defined this array called parent. So so to write the find function, so basically what we have to do, if parent of x, so we have to find the parent of x. But if x is the, like, if parent of x is x itself, which means he is at the top of the the parent tree. So if he's at the top, then if so, basically parent of x. So I will write here x minus 1 because this array is zero index and our candidates are one index in our input. So I'll write x minus 1 over here. So if parent of x minus 1 is x, then what we have to do? We have to return x. So basically, we are searching for the parent of x, but he himself is his parent. So we just return the number, and else if he is not the parent of himself. So what we do? We define parent of x.
No, I didn't get you why your parent of x minus 1 is equal to x.
Acha, why did I write minus 1?
Yeah.
Yeah. So in design, okay. So initially I defined my parent array as 1, 2, right? Like, so we have some submissions. And initially ith person, like the first person is the own. So suppose we have some score as 5, 4. So the owner of the submission number 5 is guy with integer, like guy with index 1. Thus, owner of submission with score 4 is guy with integer number 2. Do you get this?
Yeah.
So, but when I try to access, but when I try to write it as a parent of, like when I try to write, like in Python the
Okay. It will start from index 0.
0. That's
Okay.
zero index. So basically, what I will do, if a parent of x minus 1 is this, else what I will do, if parent of x minus 1 is not this guy, I will write parent of x minus 1 is not itself. So I will actually have to find a parent of this guy's parent. So so what I'm actually doing, so suppose okay. Suppose I have 1, 2, 3. Like I have the submissions as 1, 2, 3, and in parent index I have initially I have 1, 2, and 3 itself. Now what I do, if I like face off between these two candidates, so the candidate number 3 will win over 2. So due to which what will happen? So the ownership of ownership of this submission will go to the candidate 3. So the parent of 2 will be turning to 3. So the ownership of a parent 2 will be turning to 3. So basically now if I want to, and now it may also happen like this is a simple example, but it might happen that to get to the actual the top, like the topmost parent, how should I explain it? We'll have to recurse through this like the parent of parent of parent, something like that. So that's why I define basic wait, I'll have to come up with some example for now. So this is basically a find function. I'll have to think of the example to like explain why I wrote this. But is there any doubt within what I wrote? This is basically the pseudocode for find, not pseudocode, actual code for the find function in union. So if this is clear, we can move on to like, so in a disjoint set union, we have find function and we have union function. So we'll see union of two elements. So basically we want to merge two elements. So in that case, what we'll do, so in that case, what we'll do, for doing union, we should make sure that the so before doing before making a union, we should make sure that these two are have different parents. So for that, what I'll do, I'll do find of x and store it somewhere. So like in something like a parent of x is equal to find of x. It will find me the parent of x, and then parent of y is equal to find of y. This will give me a parent of x. This will give me parent of y. And if these two are not equal, so if these two are not equal, we can actually merge them. So for merging them, what we can do is so in this question, we basically have to check for which guy has the higher score, and according to that, we have to merge. So basically, yeah. So if both of the parents are not equal, so we'll check for which guy has the higher score. So if so if x is the x has greater score than y, so what we will do, parent of y will be changed to parent of x. Else, if so in this question, in the question we are given that if both of them are like both of their score is equal, we don't have to do anything else. So therefore I'm writing this if score of x is less than score of y, then I'll just replace x and y. And if both of their parents are equal, so basically here they have mentioned that if a single participant is current owner of both the submission, then we'll have to print invalid query. So here, if both of their parents are different, then we do these comparisons. Else, if both of their parents are same, we do the print invalid string. So basically, this is our find function and union function written with us. So like if a query of 0 is 1, that is if query 0 is equal to 1, so if the query is of type 0, type 1, that is this one, so basically we'll have to print find of x. Not find of x, find of queries first element. So this is query 0th element, this is query's first element, and we'll print the find of that. Else what we'll do, else we'll call the union function of union function on query's first element and query's second element. So this is the code. Like this is the complete code for this. So does anyone have any question?
So could you explain the last that union query and
this thing?
No, sir. Union last. At last, you used union again, right? Yes.
Yeah. So if so we have queries of the two type of these type where we have to report the parent of this guy, and of this type where we have to like compete between these two. So what is basically happening? Oh, sorry. So what is basically happening over here is I called union on these two numbers, right? I'll get these two numbers and I called union on that. So what will happen over here is, so my query, if my query's first element is 0, then my query will be of size 3, and the second and third number will be the participants which will be competing against each other. So I call the union function on these two. So now what will happen? I will check if both of their parents are same or not. If they are same, then I am straight away printing that invalid string, because that's what they have asked, right? That if the current owner of both the submissions is if single participants own both the submissions. So basically, if parent of X will find the owner of this submission X, and parent P of this find of I will find the owner of submission Y. If both of them have same submission, then we'll print like both of the submissions have the same parent, then we'll print invalid string, right? Else yeah, and else they have told that they have mentioned over here, the person who presents the submission with higher judges score wins the round. So like if X has his score greater than Y, then the ownership of this element, ownership of Y will go to X. So basically what we can do, we can replace the parent of this element with this. So what we are actually doing, okay. So we are trying to merge X and Y. So X has some parent PX and Y has some parent PY. Now if X and Y are facing off, so what if X and Y are facing off, so what will happen? If these two are facing each other off, so this guy, if this guy wins, so basically the ownership of Y should be transferred to this, right? But if ownership of this transfers to this, so basically what we can do, we can like change this guy's parent to this. So basically like this guy owns the entire thing. So that's what we are doing by writing this statement. And similarly, we are doing it for X. So basically, this is the code. So yeah. So any other doubts? So if there are no other doubts, maybe Gaurav can solve his problem further. Yeah. So what do you?
Hello everyone. Now we will go through a problem which was came in the February long challenge in 2022 in Codecheck, and it is based on DS1. It is a fun problem. It is not related to assignment since we have left with some time. I will just go through it so that you could have more practice with BSc problems. Let me share my screen. So hope my screen is visible. This is a problem statement. This is bitwise swaps. So the problem is we are given an array A, which has n integers from A1 to AN. And basically we want to sort this array. And the condition is we can only use this type of swap operations to sort this array. So consider any two indices I and J, where I is not equal to J. So if AI and AJ, this AND is a bitwise AND operation. I will explain what is bitwise AND. So if the bitwise AND of AI and EJ is not equal to 0, then only we can swap these two elements. So let me just go through it. So we have an array A, A1, A2, AN, length N, and we are given a swap operation, and we can only perform swap on AI and AJ if the bitwise AND of AI and AJ is not equal to 0. So bitwise and is say AI equals to 6, then the binary representation of 6 will be 110. And say if AJ equals to 4, the binary representation of 4 will be 100. The bitwise AND is just like
what's the difference between a single and double AND?
Can you repeat?
Yes, sir, we will write a single and in C++, we will write double AND. What's the difference between those?
I can't hear properly. Like C++,
So I think, yeah, so I think the question was the difference between a double AND and a single ampersand. So I guess it's the difference between a logical AND and the bitwise AND.
yeah.
Yeah.
Yeah. So in C++, like and is basically this is logical operator. So condition 1 and condition 2. So if both conditions are correct, then this will return true. And this single AND is based on this bitwise operation, so which is defined on one binary number and second binary number. So basically, if your 2 bits are 0, 0, then the AND will be 0. 0 and 1, 1 and 0, this also AND, it will return 0. And if both bits are 1, then this AND will be 1. So if we have multiple bits and say we want to do 110 and 100, then it will do bitwise ANDs. AND of 1 and 1 is 1, 1 and 0 is 0, 0 and 0 is 0. So in C++, if you do like 1, 1, so this single AND, it will return 1, 0, 0, because the AND of 1 and 1 is 1, 1 and 0 is 0, and 0 and 0 is 0. So this AND, single AND, it represents bitwise AND operation. So is there any doubt related to like bitwise AND or this single AND operation? Okay, so basically the problem is if say instead of 4 we take AJ equals to 1, then its binary representation will be 0, 0, 1. And the binary representation of 6 was 1, 1, 0. If we now do bitwise AND, so AND of 1 and 0 is 0, 1 and 0 and 0, 0 and 1 is 0. So it will equal to 0. So the question says that if for some index I and j, the AND of AI and bitwise AND of AI and AJ is equal to 0, then we cannot swap AI and AJ. So the swap operation is only allowed where the AND of bitwise AND of AI and AJ is not equal to 0. And by performing this type of swap operations, we want to sort this array. And the question is whether we can we will be able to sort this array or not. So basically, if the array is such that we won't be able to do enough number of swaps, then the array we will not be able to swap the array, right? So we want to we are given an array and we want to find using these swaps if we are able to sort the array or not. So is the problem statement clear? So I will again brief it like we are given array A1, A2 up n and length array, and if for any index I and j, I is not equal to j, the AND bitwise AND of AI and AJ is not equal to 0, then we can swap AI and AJ. This is for all I and j belongs to 1 to n. So is the problem statement clear? Okay, so does anyone have any approach or intuition like what should we do to solve this problem? Just a general intuition, like any idea that we can apply. or I will give a hint, like say if we have B, which is the sorted version of A. So basically A was A1, A2 up to A, and now we have B, which is B1 less than or equals to B2 up to less than or equals to Bn. So we have sorted A and stored it into B. Now, if we are able to show that for I from 1 to n, we can swap AI and BI. So this B1 is the smallest element of A. So it will be present somewhere in this array, right? Say it is present as AI, and AI is equal to B1, which is the smallest element of the array. Now, if we are able to swap A1 and AI, then only this minimum element will come into the first place, right? If you are not able to swap A1 and AI, then any iteration, like in any iteration, we won't be able to put AI in the first index. So we won't be able to sort A, right? So the condition is if we are able to swap AI and BI, then we are sure that we can place this say B1 on its correct place. If you are able to swap A2 with B2, then we can place B2 at its correct place. If you are able, and so on, if you are able to swap AN with BN, then we will be able to put BN at its correct place, right? So if we check this condition for all I from 1 to n, if we can swap AI with BI, then we are sure, then we can see that we can sort A. Else, just return false. If for any of the index I, we are not able to swap AI with BI, then we can show that this BI will not be in the correct place in the array A using any number of swaps. So like just using this idea, can anyone like say some intuition or what should we do to like basically we want this condition like swap of AI and BI. What should we do to find this for all AI BIs? Like anyone? If you're confused in any of the points, just tell me, I will repeat it.
So what do you mean by BI in this? Like
So
AI is the smallest element.
Yeah,
And
basically
we will
A is the given input array, and what I have done is I sorted A and I stored it inside B. So now B1 is the smallest element of A, B2 is the second smallest element of A, and BI is the ith smallest element of A. Okay. And like I'm telling that if we are able to replace A1 with B1, A2 with B2, AI with BI up to AN with BN, then we are sure that we can place B1 at its first index, B2 at second index, and up to BN at nth index. And so basically after this swaps, A will become same as B, right? And B is the sorted. So we will be able to sort A. So we just we want to find if we can swap AI with BI or not. So any idea like how can we be sure that we can swap AI with BI or not? So what if I just put like for I goes from 1 to n, if AI bitwise and with BI equals to is not equal to 0, then we will continue. Like since bitwise and is not equal to 0, we can swap AI with BI. Else we can't swap. And I will just return false. So is this approach true? Or if it's not true, then any counter example like where it fails? or it is true. Yes, someone is saying, and
Yeah, I also wanted to add that I'm not sure what is the timestamp, but Badrinath on YouTube is asking what is the condition? Is it like linear sort? So I'm not sure. I'm also not completely sure how to address that, but I thought I'll mention it.
yeah,
I don't.
is it?
It's like, is it like linear sort? I'm not sure. Like the closest that comes to mind is maybe something like bubble sort, but it's not even exactly that, because I guess you're constrained in what indices you can pick, right?
Yeah.
Correct.
So it is like we will be using swaps to sort, but we are constrained to use some particular swaps which are satisfying this condition that the bitwise end of both of those elements shouldn't be zero.
Right.
We should use two for loops, Jay is saying. Okay. But my question is whether this for loop will return correct answer or not. Like, is there any ambiguity in this approach? So like, I just want to find if I can replace like A1 with B1, I can swap it with B2. I can like swap AN with B1. And if I'm able to swap A1 with B1, so B1 will be somewhere in the array A at say AI. So I will swap it with A1 and then B1 will be at its correct place, right? A similar kind of thing I can do with A2 and B2. B2 will be somewhere present in the array set AJ. I will swap it with A2 and then B2 will be at its correct place. And we can do it for, let's say, A and BN. And to check if I can swap AI with BI, I will just put if both of their end product that bitwise end is not equal to 0. So will this condition be enough to check if I can swap these numbers or not? So it turns out that there might be the case that if the bitwise end of AI and BI is 0, and in this case also you can swap AI with BI using some intermediate swaps. So due to the constraint, you can't swap AI and BI direct. You can't swap AI with BI directly because their bitwise end is 0. But you can use some intermediate number which will like using some transitivity property, we would be able to swap AI and BI. So let's take one example. So we have three numbers X, A, and B. And the bitwise end of A and B is equal to 0. Bitwise end of X and A is not equal to 0. And bitwise end of X and B is also not equal to 0. So here bitwise end of A and B is equal to 0. But if we see, since X and A, the end is not 0, we can swap X and A. So it will become AXB. Now, since bitwise end of X and B is also not equal to 0, we can swap X with B. So it will become ABX. And again, we can do swap A with X because bitwise end of X and A is not equal to 0. So it will become XBA. So you can see that we have through this intermediate these three swap operations, we are able to swap the position of B and A, although the bitwise end of A and B is equal to 0, right? So this condition is not enough to check that we will be able to swap AI with BI or not. So we will need to do some extra work because there can be intermediate swaps that we need to count. And here I only showed one by putting one intermediate bridge or intermediate vertex. There can be two we can also have two two intermediate numbers using which you would be able to swap A and B. Say like we have A, B, X, Y, and the bitwise end of A and B is still equal to 0, but bitwise end of B and X, A and Y, and say X and Y, this is not equal to 0. So we can use these three conditions to swap A and B. So here what we can do is we can first swap A with X because A with Y, because their end is not equal to 0. So it will become Y, B, X, A. Then we can use B, swap B with X since their end is not equal to 0. So it will become Y, X, B, A. Then we can swap X and Y because their end is also not equal to 0. So it will become Y, X, B, A. Again, we can swap A with Y because their end is also not equal to 0. It will become A, X, B, Y. And wait, just a minute. So X, Y, Y, A. So here we swap X and Y, so it will become X and Y. So if we now swap A with Y, A will come here and Y will go here. And now finally, if we do swap of B and X because their end is not equal to 0, it will become B, A, X and Y. And here also you can see that we are able to swap A and B using two intermediate numbers, and the number of swaps will be 1, 2, 3, 4, 5, using 5 swaps, right? And this chain we can even continue for like 3 numbers, and there will be 7 number of swaps. And we can use any number of intermediate swaps, and we are able to swap 2 numbers, right? So basically, if we enumerate all the AI, BI, AI, AJ pairs and check if we can swap AI with AJ. So somehow we have this table, and cross and table, which with like say with ith and jth entry is 1. If we can swap AI with AJ using some intermediate swaps, right? So if we are able to create this table, then we are done, right? Then our work is done. But can someone just identify what problem will we face if we go with this approach? So if you see the constraint, I will just show you the constraint. The constraints are these. The range of n is from 1 to 10 to the power 5. So do you see any problem in creating this n cross n table? So n is from this. So if we are creating n cross n table, this will take 10 to the power 10, like n square time, right? And this will basically give you TLE. If you are trying to submit this using this approach, then CodeChef will give you TLE because this 10 to the power 10 iterations are quite more.
What is TLV?
TLE is time limit error. Basically, in each problem, like on CodeChef, in each problem, if you see, there will be some constraints. So basically, if like around 10 to the power 8 iterations, you can do it in 1 second. If you consider CPP language, then 10 to the power 8 iteration takes around approximately 1 second to execute. And if you if you are creating n cross n table, then how much iterations will we need? So n cross n here will be 10 to the power 10, right? So if 10 to the power 8 iterations requires say 1 second, then this will require around say 100 seconds, right? Which is quite more, which is not feasible in real life, right? So this approach will basically give you a TLE, which is time limit error. So your algorithm is not efficient basically. So what we can do is the constraint, the limit on the AI is up to 2 raised to 31, right? So AIs are less than or equal to less than 2 raised to 31, and if you do if you count the number of bits in binary representation of AI, then that will be at max 31, right? Because log of 2 raised to 31 will be at max 31. So we will at max we will require 31 bits to store this number. So this gives us the intuition that maybe we shouldn't use the number. We should use the binary representation, and we should use this fact that the number of bits
but
is
how log 2 power 31 is 31? Is it log to the base 10?
31 log 2. Yeah, 31 log 2. If you consider base 2, because in binary representation it will be right. If you 2 raised to 1, then it will be 1 0. 2 raised to 2, it will be 1 0 0. 2 raised to 3, it is 1 0 0 0, right? So if there are power is 3, then it will require around 4 bits. If power is 4, you will require 5 bits exact, right? So if power is 31, if A is equal to 2 raised to 30, then you will require 32 bits, but the equality is not given, it is only less than. So the number of bits required will be at max 31, right?
Yes, sir.
Yeah. So the number of bits are like constant 31. So we can do 31 into 30. Like if we do n square algorithm on this bit, so like say this is C, we can do C square algorithm and it will run like 31 square is not big enough. So basically the idea, so what the idea is here we can use DSU, and if you think like if you observe the test cases, then you will get to know this. Get to know this. You can use DSU, and this will be efficient approach to solve this problem. And basically, in DSU we have different sets, and each set as a representative was a parent. And so in this problem, what the set represents is, say we will
So
be
what is
put DSU is disjoint set union data structure that yes implemented those two functions, right? Find and union. So those find and union functions are basically part of this data structure. So you have initially you have some number of sets, and each set as a parent, like a representative. And what the find does is, if you give some element x, the find function will return the parent of the set in which x is there, right? So if say x belongs to this set, then the function that DS wrote, find of x, it will return the parent of this set. And the merge or say union function that you saw, it will say this is set A, say y belongs to this set, and z belongs to this set. This is S1, this is S2. If we do union YZ, then these two sets will get merged and will combine, and it will create a new set S1. So these two functions, find and union, we can apply on these sets, and basically this is a DSU data structure that you learned in week 4. So in this problem, since we want to represent the bits, say if we, the intuition is, say in the same set, if there are k bits, these are bits, 0, 1 bit, like say A1 equals to 1 0 0 1 0, like it is a 31 bit representation. A2 is equal to some 0 1 0, it is also 31 bit representation. So we are storing the indices of these bits. So this is first index, this is second index, this is third index, this is 31st index. So C1, C2, CK, all CIs belongs to 1 to 31. So these CIs are representing this index of bits in the representation of each AI. So if there are this say C1, C2, C3, and CK, they are in the same set, then I will introduce that these are we can say that swappable bits. What swappable bits means is like I just gave it a name, swappable bits. That it means that like say if there are two numbers AI and AJ, and say the Cith bit in AI is 1. So AI has binary representation like this 1, 1, 0, and this is the Cith bit which is 1. Same AJ has some binary representation, and this is the jth bit which is 1. So AJ has the CJth bit which is 1, and if both CI and CJ belongs to same DSU set. So this is a DSU set. If both CI and CJ belongs to both the same DSU set, then we want to say that AI, and we can basically swap AI and AJ using some intermediate swaps, right? Basically, if you think and take some example, like what it represents is if AI has a AI has a bit which is 1 at the Cith index, and AJ has a bit which is 1 at CJth index, and both CI and CJ belongs to the same set, then there exists some number which shares common bit with AI and AJ. So like if AI equals to 1001, this AJ equals to 1101. Say the fourth bit of AI is 1. The second bit of AJ is 1. We can also take other 2 bits. I'm just taking this example. So fourth bit of AI is 1. Second bit of AJ is 1. And if 2 and 4 are in the same set, then we want to say that there exists some number AK which has second and fourth bit set as well. So AK, if you see AK and AI, the fourth bit in AK and AI is 1. But if you see AK and AJ, the second bit in AK and AJ is 1. So AK shares same bit, same 1 bit with both of AI and AJ, but at different index. So if 2 and 4 are in the same set, there exists some intermediate number which shares common bits with both of AI and AJ. Right? So like formally, if we define like how we will be constructing this set, so what we'll do is we'll take the first number. First number has some set bits. Set bits means the bits which are 1, right? Because AND operator, the bitwise AND operator will will not be 0 if both of the bits of both of the numbers are 1. So like if there is 1 and 1, then only it will give 1. Otherwise it will give 0, right? So we'll take the first number. So there are some bits which are 1. So say it is the C1th bit. Let's just number it 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the first bit, 4th bit, 7th bit, and 9th bit. We'll take all these indices and we'll put in the same set, the same DSC set. So now this DSC set will handle all kind of swaps which requires A1 as an intermediate element. Because since 1 and 4 belongs to the same set, that means there exists an intermediate number A1 which has both 1 and 4 as the set bit. It has 1. And now if we again continue, we'll take A2. A2 has some representation like this. Say this is a 3rd bit, 4, 5, 6. This is a 7th bit. So here also we'll put 3 and 7 in the same set. And what this set represent is since 3 and 4 are in the same set, we can handle all kind of swaps which has 3rd and 7th bit as 1 using A2 as the intermediate number, right? But if you see that 7 already belongs to this set, and we have created new set, and 7 also belongs to this set. So these two sets will get merged because 7 is already part of this set. and this will create a new set of 1, 3, 4, 7, and 9. Basically, this is the union of since 7 can be only in one set, right? So due to this transitivity rule, this will be ended up in a same set. Like all elements will end up in the same set. And now, if you see, we have 7 and 9 in the same set, but none of the A1 or A2 has both 7th and 9th bit as well. So what does this set represent? So this set, so we saw, right, like earlier we saw that there can be one intermediate number or two intermediate numbers, or if you go further, there can be 3, 4, 5, any number of intermediate numbers, right? So here, when we had only one number, then this set represents that the intermediate number is A1. Here, this set represents that the intermediate steps involves A2. But when we merge these two sets, this set will represent that the intermediate swaps involves both A1 and A2. So the swaps we saw, like A, B, X, Y, this kind of swaps will be handled by this set. Now, if you again go to A3, and this has some set bits 1, 2, 3, 4, 1, 3, and 5. So if it has the intersection is not null with the earlier set, then it will again get merged, and it represents that all the bits in this set will handle the swaps in which A1, A2, and A3 are intermediate numbers. So basically, this is the intuition behind using the DSU in this question. So it is just the implementation will be like for I from 1 to n. We will take AI and we will consider all the bits which are set to 1 in AI. So if AI is 1, 0, 0, 1, 1, 0, 0, 1. So this is the S1th bit, this is S2th bit, this is S3, and this is some SK. This is the kth bit, SK. So this bit are 1 in the binary representation of AI. So then we'll union all of these numbers, all of these bits. Initially, all bits from 1 to 31 are singleton sets. They are they are itself their parents, and there are 31 sets in the starting. Now, for each AI, we'll take the bits which are set to 1, and we will do union or merge operation on all of those bits, and then these bits will start merging with each other. And after this n merges, we'll have final some sort of DSU structure in which some bits will be here, some bits will be here, and like some bits will be here. So now, if you want to find whether we can swap AI with AJ or not, so what we can do is, say the binary representation of AI is B1, B2 up to B31. Binary representation of AJ is A1, A2 up to A31. So we can check each of these pairs, B1, A1, B1, A2, B1, A31, and up to B31, A31. We can check each of these pairs, and we can see if any of these pair belong to the same set. So say if B1 and A2 belongs to the same set, that means there exist intermediate transition swaps through which we can swap this AI and AJ. So basically, to find if we can swap AI or AJ, if we can or we cannot, we can use this already created DSU structure. We just need to see if any of the bit pairs exist in the same DSU set. And that will imply that using some intermediate swaps, we would be able to swap AI with AJ. So the final algo, so after the final algo will look like, so for J in 1 to n, if So for j in 1 to n, we have two numbers, aj and vj. We want to check if we can swap aj with bj. So we'll go for a from 1 to 31, for b from 1 to 31. We'll see if the 8th bit of aj equal to 1 and the bit of bj equals to 1 and both a and b belongs to same set. Then we can swap ai with bi. Else we cannot swap. So the swap condition that we wrote, if you see the time complexity is the 31 square. So it is far more, it is 2 more less than the 9 square, right? So this is, using this DSU, we have reduced this time complexity very efficiently. And if this condition is true for all j from 1 to n, then only we are sure that we will be able to sort a. Like finally we'll be able to convert a to b. So that means we have sorted a. Okay, I know like this is slightly confusing, but if you want any point to be repeated, I will repeat. Just let me know like if you find something confusing or want to repeat me anything. I will also show the implementation. I'll just implementation code. Just a minute.
So Gaurav, if it was a bitwise OR instead of a bitwise AND, would it be kind of similar, the approach?
In bitwise OR, there will be 3 conditions in which we will be able to swap. So I think we can merge the sets if 0 and 1, 1 and 0, 1, 1. We don't merge if there is 0, 0.
Yeah, something like that. Yeah,
I think that intuitively that should work. If there is some edge case, then we need to think.
Right.
It.
Actually, when you shared the question the first time I read it, instead of AND, I somehow thought of it as XOR, the XOR operation. And I was very confused because XOR I think the only case when you won't be able to swap is when the numbers are the same, right?
Yeah.
Because if the XOR is 1, I think that would mean that the numbers are identical, right? Because an exclusive OR is 1 whenever the inputs are equal, right?
Yes, AB complement plus B complement.
Right, something like that.
So
in that case, I think it is a lot like maybe just like your normal bubble sort or something like that. So there will be nothing to check. So then I was just curious about the role played by the operation that is being used. So the operation definitely matters in the sense that there are operations for which it's not a serious constraint at all. But for OR versus AND, I think maybe something symmetric would work. So yeah. So yeah,
in OR maybe like the computation will be more than AND, I guess.
Yeah.
Because the constraint is like lighter than AND.
Right. Makes sense. Okay, yeah, but this is a pretty cool problem, quite nice. So yeah, maybe you want to go ahead and share your code. I'll just quickly check if there are any other questions on YouTube. I think
just share this.
Yeah, no, I don't see any explicit questions. So people liking the problem. So yeah, please.
So like this is the implementation of the same thing that I explained in C++. So first, like we are initializing the DSU parent array, which is of size 31. And this is the find function that is same as the yes implemented. So we want to find the parent of A. So if the parent of A is A itself, then we will return A. If not, then we will need to recurse further to find the parent of A. So we will again call this function find of parent of A. So this is basically a recursive function which will at the end will return the parent of A. And here the merge function is simpler than what we saw in earlier problem, because in earlier problem we also wanted to check the condition which has the larger size. Here we don't need to check that condition. So basically we will just find the parent of A, we'll find the parent of B, and if both of them are same, then nothing to do. If both of them are different, then we'll assign one to be the parent of other. So parent of A will be will be B. So we have merged these two sets. So here I just test cases. This is N as the input. This is I initialize this parents array with I. So parent of I is I. That means initially we have 31 singleton sets, or I think that's 0. So there are 31 singleton sets, each of them are initialized with like itself as a parent. Then here we are also taking we are storing the input in both of A and B, and we will sort B just to check the condition, right? So we will have two arrays A and B. B will be the sorted one and A will be the original input. So now to update the DSU structure, what we'll do, we'll go through each element of A, and now we will go through the each of the bit of A. So there are order 31 square possibilities. So we will check the which of the two bits can be which of the two bits we can merge. Like say the jth bit of A is 1 and j plus 1th bit of A is 1. So we can merge these two bits, because basically we want to merge all the set bits of the AI. So we can get all that through like these two for loops. Here we are just here 1LL. This basically means 2 raised to j. So 2 raised to j. So the representation of 2 raised to j will be 1, and after that there will be j zeros. So if we do AND of this number with AI, it will be same as the ith bit of A. So if ith bit of A is 1, the AND will return 1. If the ith bit of A is 0, not I, this is j, because this 2 raised to j has 1 at that jth bit. So if the jth bit of A is 1, then this AND will return 1. And if the jth bit of A is 0, then this AND will return 0. The same here. If the kth bit of A is 1, then it will return 1, else it will return 0. So this is just to make the computation efficient. So it will just check if the jth bit of A is 1 and the kth bit of A is 1. So if j and k, both of the bits of A are 1, then we will just merge those j and k. And this will do for all the numbers in the array. So like basically these 3 for loops will update the entire DSU data structure. Now we have the DSU data structure ready. So we now just want to check if we swap each AI with PI. So we'll initialize this integer, like we can sort with 1. Now we'll go through each element of A and B. So if AI and BI both are 0, then we'll just handle this edge case. Like if both are 0, that means both of them are minimum. So the minimum bound on AI is given 0 in the question. So if it is 0, then we don't have any bit which is set to 1. So this will return false. So we have individually handle this edge case. So if both of them are 0, then we already know that this 0 is in the correct place, and we will continue. If they are different from 0, then we'll initialize that we may not be able to swap this element. So initially we just assume that this is bad swap. We want to be able to swap it. Now we will check each of the bit of AI and BI. So say this is the jth bit of AI and this is the kth bit of AI. If the jth bit of AI is 1, if the kth bit of BI is 1, and both j and k bit belongs to the same set. So here like the jth bit of AI is 1, kth bit of BI is 1. That means the AI and BI has one has a bit which is set to 1, and both J and K belongs to the set, means which belongs to the same set. So there exists an intermediate number which shares common bit with AI and BI. So this number will have both J and K bits set to 1. So its jth bit is shared with A and its kth bit is shared with B. If we are using only one intermediate number, if we are using more intermediate numbers, say 2 or 3, then that will again we need to compute, like we can first swap the below two numbers, then we can swap like using like a higher number of swaps, we would be able to swap AI with BI if this condition is true. So if we have such condition, then we are sure that we'll be able to swap AI with BI. So we'll just I'll just updated this variable with 0. And if this variable is 1, that means this condition is not true for any of the J and K bit, then we won't be able to swap AI with BI. So if can bed is still 1 after executing these 2 for loops, then this can sort will be updated to 0. That means we will not be able to sort this array. We can also add a break statement here, because if any of the, like at any I, if this can sort becomes 0, then we won't be able to sort this array. So like after this also, if can sort remains 1, then we are sure that we will be able to sort this array, and else no. So like this is the basic implementation of this this problem. And on the code chef only, I'll share this link also. There is also a video tutorial available here. You can also refer to this, and you can try submitting your approach, and whatever I explained, you can code it in the any code programming language that you are comfortable with, and you can try submitting it and see if it is getting accepted or not. I will share the this problem link in the chat. Okay, so does anyone have any confusion or doubt that whatever I have explained in this problem?
Yeah, I think some people are requesting for the problem link on YouTube. I think we cannot really post the link there, but maybe what I'll post is the problem code. So it's called bit swaps, I think.
Yeah, bit swaps.
Recent
bitwise swaps.
Yeah. Right. I think the problem code in the URL is bit swaps, and I think it looks like it was a February long challenge version 3 problem, right?
Yes.
So it was Feb 2022 div 3 long challenge. Yeah, I think that should hopefully help you find it. I think Rudra Pratap Singh was asking that question. C or C++, I think Gaurav's implementation was in C++. If I know. But you can probably do something very similar with C. So if you look at the official GitHub repository for the course, the DSU implementations are given in C, C++, Python, and Java. So you can take your pick, and so the basic, merge and find operations are implemented, but you'll have to, of course, implement the logic specific to this problem on your own. So good luck with that. I don't think if you've attended this session throughout, and I'm assuming you don't have doubts so far. Let me just see if. Yeah, I don't think there's anything in the chat. So, yeah, the editorial is a great backup resource, but my guess is that by now you probably have everything you need to go ahead and implement. So please do that. Enjoy your practice, and continue participating in contests until we meet the next time. Just a very quick announcement. Unfortunately, we had some technical hiccups with the week 5 programming assignment. Hence, we have released the week 5 and week 6 assignments together, and they both have a deadline of next Friday. And I think from here on out, every week we'll have one programming assignment each, and they're all scheduled to release under like the standard timeline. So I'll post a more detailed update on Discord in the announcement section. So please watch out for that. And thanks to everyone for joining and for the nice discussion in this live session. And thanks to Gaurav and Yash for the very nice explanations. Yeah. So with that, I think we can close this session and we'll see you all next week. Thank you. So, Mr. Karthik, I think we can close the live stream also. And I think we can call it a evening for this session. Thank you so much, and sorry that we spilled over a little bit. Yeah. So Yash and Gaurav, feel free to log off. I'll just be here till the live session is stopped, I guess.
Okay.
Thank you.
Thank
Yeah.
you.
Yeah. All right. Bye bye.